Pomodoro Joe for Wednesday, January 18th, 2023. As you can see, I'm getting a late start, so we won't be earning any coins today. We'll be doing LeetCode problem 918, maximum sum circular subarray. It's a medium problem, and the problem statement says, given a circular integer array, nums, of length n, return the maximum possible sum of a non-empty subarray of nums. A circular array means that the end of the array connects to the beginning of the array. Formally, the next element of nums index I is nums at I plus 1 mod n, and the previous element at nums index I is nums I minus 1 plus n mod n. A subarray may only contain each element of the fixed buffer nums at most once. Formally, a subarray, nums index I plus 1, up to nums j, there does not exist an I less than or equal to k1, k2 less than or equal to j, with k1 mod n equal to k2 mod n. That's just the long formal way of saying you can't use the same element twice, even if you wrap around the buffer. Okay, so this is a maximum subarray problem. It's a maximum subarray problem with a twist because we have this circular subarray. So let's set 25 minutes on a Pomodoro timer and get started. All right, so for the traditional maximum subarray problem, we can go through our subarray. So let's just grab this one as our example here. So we'll go through our subarray to start from left to right, grab an element, and then move on to the next element and check if the sum of the two elements as a subarray is greater than or equal to the new element by itself. So essentially you're saying, is everything to the left of this new element going to contribute to my maximum sum, or is it going to take away from my maximum sum, or does it not contribute at all? And if it doesn't contribute, or if it's going to take away, if it's negative, then you can just ignore everything to the left and start a new subarray starting at your current element. So in the example here, you have 1, that's good, that's a positive start. Then you go to -2. So 1 plus -2 gives you -1. That's greater than if we just started a new subarray at -2. So far, our best answer would be 1 and -2. Then we move on to the next one, 3. So we have 1 and -2, which is -1 plus 3, going to give us a 2 if we include the entire subarray, 1, -2, 3. Or we could just start an entirely new subarray at 3 and be ahead by having a total sum of 3 instead of our 2. So that's essentially what we'll be doing. We'll be going through one element at a time, checking to see if the maximum sum that includes the elements to the left is greater than or equal to just starting a new subarray at this current element. So that's going to give us our maximum subarray without the circular part. So let's start with the non-circular part, and then we'll come back to the circular part. I'll start with some result, and in fact, we will have nums at 0 as our result to start with, because we want, at least it says here, it has to be a non-empty subarray. Let's do a quick check of constraints, and it looks like nums has to be at least 1, so we won't have to worry about an index out of bounds by doing this. Now we want to keep our running maximum so far. So I'll keep, what do I call this? I'll just call this like current max. And that's also going to be equal to nums at 0. So we have some result that we'll return, and we'll return our result. And we have some current maximum, which is the current maximum that we've got from wherever we decided to start our current subarray. In this case, we're starting at nums of 0. Okay, then we'll go for I in range. And because we already have nums of 0, we can start at 1 and go to length of nums. So now we'll have to do a little bit of work to figure out which is better, starting a new subarray at our current element or including all the elements to the left. So I'll break this down into two pieces. So we'll have option A, and that's going to be, let's include everything. So that's going to be our current max plus nums at this current element. Option B is we're starting a whole new subarray now. Let's ignore everything that came before. And that's just going to be nums at our current element, I. And now moving forward, we basically just want to say, well, let's say our current max, do we want to start a new subarray or do we want to include everything that came before? So our current max is going to be equal to the maximum of our option A or option B. We can also check our result here. So our current result, we can say, oh, well, our result is either the result, the maximum of our current result, or our current max. And then we return our result. So this is sort of a standard way of getting your maximum subarray, but this doesn't include the circular part. So if I run this, we might pass some of these, but we probably won't. Well, we'll probably pass some, but we'll probably fail some. Let's just give it a shot and see what happens. So we pass 2, but we fail this third case, or this second case. So the second case we fail, I think, because, yes, we're outputting 7, which is 5, 5, and 3. So we basically took the sum of the whole array. When the real answer is 10, because it wraps, you can take the last element and then take the first element. So we're not including the wrap. How do we figure out that wrap? That's a tricky part. But there's a clever way of handling this one, which is essentially saying, okay, we've already figured out our maximum subarray here. What if we figure out the minimum subarray we could possibly have? And if we take the minimum subarray, because this loops around, that means we can essentially remove the minimum subarray, leaving a maximum subarray. So how do we picture this? I guess you can picture it in this example saying, okay, if we went through this to find the minimum subarray we could find, in our case, that's going to be -3, we could just remove that minimum subarray, -3, and what's left over is the maximum subarray. Okay, in order to do that though, we want to find the sum of the entire array, and then we'll subtract the minimum subarray. So now we're going to keep track of not just our current max, we also need our current min. I'm still going to start out at num0. Okay, and then we also need our total, and we'll start that out at nums of 0 as well. All right, so we're going to keep our existing maximum stuff. Now we have an option C though, and option C is going to be, we're looking for the minimum. So that's going to be our current min plus nums. So it's the same basic concept, but instead of looking for a maximum value here, we're going to be looking for our minimum value. So now the current min is going to be equal to the min of option, let's see, option B is our common element. So we'll have option C, which is our next possible min, or option B, which is just starting a new subarray from this element. And we will also keep track of our total. Nums at I. Okay. The other option is, let's see, I'll call this like subtract min option. So basically, this is our option of saying, let's calculate our minimum possible subarray, and anything that's left over, like after we subtract it from the total, is going to be our maximum. So that's our total minus our min, our current min. Okay. Now the only problem that we run into here is what happens if the entire array has negative values. If the entire array has negative values, then our minimum is going to be the maximum minimum it could be. And when we subtract the total from basically, or we subtract the minimum from the total, it's going to equal 0. We're going to run into 0 if we have every element in the array is the minimum. Yeah, that's a problem. So now what we'll have to do is say, we'll return result if, let's see, maybe I'll make this a little bit clearer. So I'll just say result will equal result. I basically want to say the maximum of result or this subtract min option. But that's only if the subtract min option isn't 0. And the reason for that, it's again kind of tricky, but the reason for this is, let's say the entire array will be negative numbers. Then every time through this, we're constantly getting a greater and greater minimum, like we're basically going further and further into the negative. This current min is essentially going to be every element in our array. The total will also be every element in the array as well. So when you say the total minus this large negative number, which is basically the same thing as the total, you end up with this being 0. Here's a better way to do it. If total is not equal to our current min, maybe that's a better way to do it. Will that be right? Yeah, I think that would work. And then finally, we do return a result. Okay, sorry, I'm a little bit babbly on this one. Oh, that does not work. What am I missing? Maybe I do want to actually check if it's not 0. I think these would be the same. That still doesn't work. What am I missing? Oh, I think it's because it's similar to how this result I needed to keep around because of the very first element isn't included in this current min. I think that's the problem that I'm running into. So I might need to keep something similar to like this result, except have a min result. Okay, let's see if that makes it any better. And then instead of doing the current min, I will be doing the min result. Okay, so that was the problem. I wasn't keeping track of the full minimum because I was missing out on the very first element. Let's submit this and see how well we do, because we're basically out of time. Okay, we pass. We could do better in terms of runtime. This only beats 56% of other algorithms. It only beats 40% in terms of memory, but we are out of time, so I'm going to leave it there. There's definitely things you can clean up, like you don't need all these options. I just made these temporary variables there for clarity. Okay, hope this helped. Hope you learned something. Hope you had fun. Please write better code.